Hi everyone, in this video we're going to talk about everything that we know about intercepts. So let's start with the x-intercept of a graph. This is just where the graph crosses the x-axis. So let's first say how we find them graphically. We just look at the graph and determine the point where it crosses the axis. Oops, let's do that. So where it crosses the x-axis. So it's pretty easy to do once you have the graph. So here's one place where it crosses the x-axis. Then we continue along the graph. Here's another. Continue going, and it crosses once more. So the x-intercepts are just the coordinates of these points. So this one is at 1, 0. This one's at 4, 0. And this one's at -2, 0. So to be an x-intercept, if you're crossing the graph, if you're crossing the x-axis, your y-coordinate is 0. So to find x-intercepts algebraically, we use this idea that the y-coordinate should be 0. So the way that we do it is we set y, or sometimes it's written as f of x, to be 0, and solve for x. So let's do an example together. We want to find the x-intercepts of f of x equal x cubed minus 4x. So step 1 is set f of x as 0. So I'll just replace f of x with 0. And now step 2 is solve for x. And this is where things can get a little tricky, but that's why we spent so much time talking about factoring, because that's how you solve an equation like this, which is set equal to 0. So I'll factor out a common factor of x. So from the first term, I'm left with x squared. From the second, I'm left with 4. This factors even further, so 0 equals x times x plus 2 times x minus 2. And what this says is either x equals 0, x plus 2 equals 0, or x minus 2 equals 0, because I have 3 things which multiply to 0, so at least one of them is 0. So that's one solution for x. The second case gives x minus 2 as a solution, and the third case gives x plus 2 equals a solution. So that means that the x-intercepts are 0, 0, -2, 0, and 2, 0. So that's all there is to it. Now I just make these the x coordinates, and I know the y coordinate is 0 because I set it to be the case. So that's my final answer. You always want to make sure that you've written the x-intercepts as points, not just these solutions to the equation. So moving on now to y-intercepts, it's the same idea. The y-intercept is the point where the graph crosses the y-axis. So graphically, we just look along the y-axis and we see where the graph crosses. It crosses right there. The coordinates of this point are 0, 4. So a y-intercept has to be on the y-axis, which means the x coordinate is 0. we use that idea when we come up with the strategy for finding it algebraically. In this case, we set x equal to 0, i.e. plug in 0 for x, and then solve for y. And sometimes we're considering y as f of x, so we might be solving for f of x. So really, we're just finding f of 0, right? I'm plugging in 0 for x. So to find the y-intercept of this same example, I'm going to look at f of 0. So that will be 0 cubed minus 4 times 0. So that says the y-coordinate of the intercept is 0. And we know that the x-coordinate was already 0. So the y-intercept is 0, 0. Okay, so here are some weird graphical examples. If we look at the graph of this parabola, so a quadratic function, where I've added 1. So here's what I've done. I've taken the parabola, the normal one, and I pushed it up by 1. This one has no x-intercepts. So it is possible to have a graph that never crosses the x-axis. If I look at this function, which we'll study a lot in the second semester, this is f of x equals sine of x. This one has lots of x-intercepts, here, 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 and they keep on going. So this is another strange example because it has infinitely many x-intercepts. So you can have 1, 2, none, 5, a million x-intercepts. But with y-intercepts, this graph has 1, 2, 3 y-intercepts. But the problem with this is it fails the vertical line test. Here's a vertical line that crosses in 3 points. So this one's not a function. And so in general, it's true that any function can have at most 1 y-intercept. Otherwise, you'd be crossing the y-axis more than 1. The y-axis itself would give you the vertical line that shows that it's not a function. So any function has at most 1 y-intercept. And that's just sort of a neat fact. Okay, so I hope that this has summarized well all the ideas of intercepts, and please let me know if you have any questions.